Welcome to the channel. Good day everyone. Today we are going to be solving a question on mesuration, solid mesuration. The diagram shows a wooden structure in the form of a cone mounted on a hemispherical base. The vertical height of the cone is 48 meters and the base radius is 14 meters. Calculate correct to three significant figures the surface area of the structure. Now let's go straight to the solution. The shape is made up of cone and hemisphere. As you can see in the diagram, the cone and hemisphere. Cone mounted on the hemisphere to produce a single shape, as you can see in the diagram. Now, we are given the height h to be 48 meters. We are given the base radius r to be 14 meters. Now, you will notice that the cone has two surfaces. I labeled them 1 and 2, as you can see. While the hemisphere also has two surfaces. The curved surface, which is 1, and the circular surface, which is 2. Now, let's take them one by one. In cone, the first one, the one I labeled 1, is the curved surface. The one I labeled 2 is the circular surface. Likewise, in hemisphere, the one I labeled 1 is the curved surface, while the one I labeled 2 is the circular surface. Now, place the cone on the hemisphere. You will notice that after mounting the cone on the hemisphere, the circular surface 2 will not show again. Look at that 2. That 2 will not show again after mounting it, which means there is no more surface. There is no more circular surface. So we are left with the curved surface for cone and curved surface for hemisphere. Therefore, the formula for finding surface area of the structure will be curved surface area of the cone plus curved surface area of the hemisphere. So that is the formula we are going to use. Now, let's take it one by one. Curved surface area of the cone. What's the formula? The formula is pi r L. To get the curved surface area of the cone, it is pi r L. Also, the curved surface area of the hemisphere, the formula is 2 pi r square. 2 pi r square. So adding the two together will give us the surface area of the structure. But to find pi r L, we need L. So using Pythagoras theorem, we are going to find L. L square equals 48 square plus 14 square, which is 2,304 plus 186. Adding them together will give us 2,500. Find the square root of 2,500 and that will give us 50 meters. So the slant height is 50 meters. Now we can easily find the surface area of the structure. Now let's input the formula. We have pi r L plus 2 pi r square. Now let us factorize because pi r is common. So let's bring pi r out. So when we bring pi r out, we have pi r into brackets L plus 2r. Now let's do the calculation. Pi multiplied by 14, which is r, into brackets length, slant height, 50 plus 2 times 14 into brackets, that's meter square. So we have 14 pi into bracket 50 plus 28, which is 2 times 14. Then 14 pi into bracket 78. Do the calculation. Pi is 22 over 7. Do the calculation. It will give you 3,432 meters square. But if you look at the question, we are told to correct it to the three significant figures. So the answer is 3,430. Okay, thank you for watching. Make sure you subscribe to the channel. Thank you.